Good afternoon and welcome to this Chemistry World webinar. I'm Ben Valsler, Chemistry World's digital editor, and I'm delighted to have quite an unusual webinar for you today. Normally we look at tools, products, processes and talk about how good they are and how well they work and why you should perhaps change your mind or invest in a new system and so on. But today we're looking more at people, at influencers, at the contagious nature of enthusiasm for new processes and practices. And specifically, we are looking at the tools of digital chemistry, but the things we're talking about today really apply across the board to any new approach, any new tool, any new product that you happen to like, that you think really can help to make a difference in the organization that you work with. So although we are specifically talking about the tools of digital chemistry, and within that we're talking about JUMP and the design of experiments mindset, I'm certain that you will have lessons that you can pick up from the next hour that you can apply to any change that you would like to see in your organization. So data analytics is increasingly playing an imperative role in the move towards digitization in chemistry. And there's really overwhelming consensus that these sorts of tools, analytic approaches, statistical approaches are where we need to go in terms of digitization. But there are many organizations who are sort of dragging their heels a little bit on this because of various organizational level issues, momentum, staffing, expertise, access to tools, and so on. Over the course of the next hour, we're going to give you some quite rare insight into how chemists and scientific leaders can work together to build consensus and lay the foundations for digital chemistry's implementation. So there are sort of two sections to today's webinar. We have a video section, and I'll explain why we pre-recorded it in a minute. And then we have a demonstration of JUMP itself and the Q&A with our guests who are also featured in the video. Now, the one person who can't be with us live today is Elizabeth Rousel, who's Director of Johnson Matthey's Technology Centres. As you can imagine, with a role like that, her time is very stretched, and we wanted to make sure that we could sit down with her, ask all of the questions that we wanted to, and make sure she was comfortable enough to have what is really a disarmingly honest conversation about the machinations of organisational politic, about how one person within an organisation can influence up the chain and outwards in order to make serious level change at strategic level. And the other speakers we have, Pilar Gomez-Jimenez, who is a principal scientist at Johnson Matthey, and we also have Stephen Poulston, another Johnson Matthey research manager, in fact. So Pilar's on screen, and we've got Stephen as well. They were involved in this process. Pilar, very much an influencer within Johnson Matthey, very much a fan of the design of experiments mindset, managed to push that contagion around the organization and make more and more people realize that this really is the best way to be doing experiments. How did she do that? We'll find out from the chat. We're also going to be joined a little bit later on by Phil Kay, who many of you who will have attended Chemistry World webinars before will be familiar with. Phil is, of course, an expert at design of experiments, a key representative of JUMP in Chemistry World webinars. He's going to be showing us how you can use these tools to lead to the sorts of evidence and examples that you need to give in order to make these sorts of changes. So we'll say goodbye to the three of you for now. We will pick you up again after the video has played out. We're also going to drop a few polls in during the video to make sure that you know exactly where we are. And it's very important that I thank JUMP today, because although most of our guests are from Johnson Matthey, JUMP are a regular Chemistry World webinar partner. Any of you who have joined us for webinars on design of experiments and similar things before will be familiar with JUMP. We've demonstrated over and over again how their tools and the statistical approaches that underpin them can really make a big difference to you as a researcher in terms of your efficiency in the experiments you do, how quickly you can get to the answers that you want, and also how well you can communicate those answers using JUMP as a tool. So it's always great for us to partner with JUMP. We know they do a lot of work for chemists around the world, and they're a great partner for Chemistry World, so thank you. And it was JUMP who brought us this case study. They told us there was somebody who, just using their influence and the tools that JUMP provides, they were able to lead to this sort of strategic level change within a global chemicals company, Johnson Matthey. So thank you, Jump, for bringing that. We will go into the first video very soon, but in the meantime, if you have any questions, do keep them coming in. We will have plenty of time for Q&A towards the end of the video, so do please get your questions in. There should be a box somewhere on screen. It might be labelled chat, it might be labelled questions, that depends what platform you're on, but keep them coming in throughout the videos and the polls, and then we'll put them to our expert speakers at the end of the presentation. So that is all from me for now. Let's get into the first part of the video. So this is myself, although you will see I'm wearing something very different. This was recorded a couple of weeks back. Elizabeth Rousell, again, Director of Johnson Matthey's Technology Centres, Pilar and Stephen, who you've already seen on screen, talking about how to influence change within a big organisation and the power of the design of experiments mindset. Off we go. Liz, Stephen, thank you for joining us. You've both had long careers at Johnson Matthey. During that time, how have you seen analytics culture progressing and evolving? And have there been any real key moments where you thought things are different now?
I have been at Johnson Matthey a long time, and when I first joined, I would say that the culture was experiments, single experiments, learn from that, next single experiment.
Yeah.
I think over the years, people have realised that they can be much more efficient in their innovation by using good design of experimentation. So that's thinking hard before you start, planning your experiments, and I'm sure when you talk to Stephen and Pilar, they'll explain how they've been able to reduce the number of practical experiments they need to do in order to get to the answer more quickly.
And has this all come from within, from your own researchers realising there are more efficient processes, or have there been external factors that have fostered this change?
I think the marketplace actually is driving efficiencies in R&D, and it is requiring faster innovation. The world is just a much faster place than it used to be. So I think there are external factors, and I think there are internal factors. And we, at the time, many years ago, when we had a health business, the pharma industry was leading in this space, and we learned from our colleagues in that business how to use design of experimentation, and that's where we started. The advent of high throughput experimentation also helped, and that was quite clumsy to begin with. And the equipment that you could buy was sometimes not as fast as a human being doing the same thing.
Yeah.
So those were the early stages of trying to use automation as well. But I think the combination of design of experimentation with good high throughput equipment and process has really been quite an eye-opener in R&D.
Pilar, if we could bring you in here. The concept we've been talking about really was the birth of digital chemistry. Could you give us an overview of, from your perspective, what digital chemistry is and what it means for a working scientist?
That is a difficult question, because I think digital chemistry is one of these words everyone uses, and everyone uses kind of very differently and means different things. So what it means for me, digital chemistry means that the information, everything that we learn, is not going to stay in a notebook. It's going to pass. It's going to be transferred to the business between the different functions in a company. It's going to be transferred during the time. So it used to when I started and you start doing something, it's like, oh, you need to talk to this person that has a lot of experience on this, and the experience that person has, he only or she only can tell you. There is no. So for me, digital chemistry is for me having a model, for example, that I can transfer to someone else and say, yes, you can use this model, because this is having everything that we have researched. So it's about transferring within function, and it's about being able to transfer the understanding, the knowledge, the experience, as well through the time. So people can use it and they don't have to continually be reinventing the wheel. So that's for me what digital chemistry is.
And Liz, from a leadership perspective, this obviously means more people have access to more data, the turnover is quicker and so on. How does a digital chemistry approach affect your role in leadership?
I think it's all about trying to innovate more quickly, because the markets are so fast moving. So to be really competitive, you've got to be very fast in your innovation, and that means everything from research through to revenue. So it definitely is important to understand how you can make your innovation pipeline more efficient. So speed to commercialization is very key. I think the other thing is it's a big culture change as well. So for me as a leader, I recognise that this is a culture change and we're asking people to behave differently, and that actually is quite hard. And so you have to show people some really good case studies, which Pilar and Stephen have, to try and encourage people to understand why they should adopt this process. You know, why use automation? Why use design of experimentation? Why should I not write things down? Why should I use an electronic lab notebook? That kind of thing is a culture change. And we're working hard with our colleagues to try and make sure that we can change the way we behave, to make sure our data's in the right place, structured, can be accessed. And it really is all about speed to market.
So is that the biggest challenge, getting people to adopt, getting people to change, training them up in new techniques? Or is there also the issue of just not having the latest equipment, not having the latest version of software, not having a fast enough machine or a good enough network and access to all of your different offices around the world? Yeah,
I think it's a combination of those two things, isn't it? Because when you're implementing something, you're always trying to make sure that you get this balance between standardization and fit for purpose use, depending on where you sit in your different businesses. That's a difficult balance. You don't want something that's so bespoke that you would never finish implementing. So that is a challenge, but I think the behaviour piece shouldn't be underestimated. You know, we are asking people to behave differently, and once you feel the benefit of that, I mean, Pilar, you probably would agree. You really you're almost a convert straight away once you've realised for yourself the benefit of taking that approach.
Yes.
And I think to some extent scientists are quite rightly naturally sceptical about things, aren't they? They like to be able to see the benefit and understand the benefit and do the experiment themselves to understand. They don't like to just take it, all right, you know, this is good for you, therefore you should do it. They like to be able to see that for themselves, don't they?
They are very smart people. So you cannot impose things on them. They have to understand why they are doing it like that, and they need to do it by themselves. So it means that they can see, oh, this person has done this and it has this great value, but then they have to do it themselves to actually believe it. Well, that's where scientists is, someone that proves things, so they need to prove it.
They need to see the evidence before they'll adopt it.
Yeah.
And how have you been able to adopt that approach in terms of sort of planning for the future? How have you put this vision into action at Johnson Matthey?
We have tried to address the problem statements in bite-sized chunks and try and create a roadmap. But there are, it's everything from good design of experimentation, simulation, computational modelling, high throughput and automation, and then the right digital tools. So we're trying to make sure that we've got each of those steps in place, and we are definitely on a journey, and we are not there. I don't know many companies that would say they've landed and they're there. I think we're all on this journey, and constantly the tools are changing and upgrading, which is fantastic. And like any business, there'll be some parts of the business that are slightly further ahead than others, and that's good in a way because you want people to pull others through. So I think there is certain areas where I feel we're very strong in, and there are other areas that we definitely need to be stronger in.
Yeah, but I mean, I think one of the good things about some of the technology that are available now, they're a lot more accessible. They're sort of more user friendly. I mean, in terms of cost, they're more reasonable. And in some ways, the technology that's available now, it sort of democratizes the whole digital economy in science, doesn't it? I think it enables people to access that because I guess people like me, right? There are lots of people at Johnson Matthey younger than me, right? But wouldn't necessarily have that background in statistics or in some of the sort of software or the detailed use of computers that perhaps would be more common now. And so to introduce that technology and to train people so they can use it, I think it can be quite a hurdle if it's difficult. If you make things difficult, people don't want to use it, do they? But I think that's the beauty of it now. I think a lot of these technologies are much more accessible to people who actually aren't necessarily data engineers or statisticians or mathematicians. They're chemists, right? People like me, so the background is different.
Exactly, and that's what we have understood. I think we have understood that it's a lot more beneficial that everyone is able to do it. If we get these scientists that are very knowledgeable in their field, and we manage to upscale them in using statistical tools, the combination is amazing.
Yeah.
So because it's very difficult it will be very difficult to teach a statistician what people in a company knows about chemistry.
I think we should, biologists typically are much better at this than chemists. Statistical analysis,
By
they're
training.
brought up in that way, and that's how they're trained. So they have an advantage, and thankfully we do have a team of biologists that work with us. But I think your point is really well made. If we can make it as simple as possible to enable people to be able to do design of experiments, that's the beauty of it.
Yeah,
isn't
and
it?
use machine learning and things.
Yeah.
There is nothing dark about it. Everyone can do it, and they will do it at different levels. But there will be different levels, people helping each other. It's kind of, I see it as kind of a pyramid in which everyone is supporting each other because they are all very able. They are all very smart people.
Yeah, and you do need, at the apex of your pyramid, you do need the specialists to be able to support and to train and to give people additional advice. But I guess you don't want it to be the preserve of an elite
minority.
at the top.
Yeah.
You want everybody to be able to have access to it. And I think
Federated.
Exactly.
Thank you very much. That was part one. We still have two more parts of that conversation. Really deep, insightful conversation. We were very lucky, very privileged to have Elizabeth Rousell with us, along with our esteemed guests who also have joined us today. Now, what we're going to do is run a quick poll, and then we're going to go into part two of the video. Some good questions and comments coming in already. Please do keep them coming in. One that we always get, somebody asking whether we'll get a certificate for attending this. Everybody who attends live will receive a certificate in a few days' time, where we'll send you an email that also has a link to the recorded version of today's webinar. So if you miss anything, if you have any technical problems, or if you just want to watch it again, you'll get a link to the recording in your email in 48 hours time, something like that. So let's get that first poll up on screen and see where you stand in your own design of experiments journey. So do you already implement design of experiments in your daily work? Please do answer. It's really useful for us to get to know our audience. It helps us with the questions at the end, because I know whether, if all of you already use DOE, then I can really drill into Phil K for some concrete examples of expert level DOE. If none of you have used JUMP and design of experiments before, then we know we start in a different place. So please keep your questions coming in, keep your comments coming in, fill in the poll. I'm keeping an eye on how many people have voted. I'm going to let it get a little bit higher before I move on. So let me have a look and see if there are any good questions that we can, or that I can answer for now. I'm going to put this to Phil again later, because I know Phil has some great examples, but we have had a question about short courses on JUMP, and I can tell you that JUMP offer an awful lot of really good resources, as well as a really active community who can help you. But just a few weeks ago, we had a 3-part workshop that really would show you the grounding, the basics, both in the sort of theory behind it and the practice of it. Have a look at chemistryworld.com/webinars. You will see that course, that 3-part course, in the webinars page, just under a couple of the upcoming webinars. Do please check that out. Also, we shared the link for you there. Thank you, Born, for your question. But yeah, we can chat with Phil. Phil knows a great deal about the support that's available for JUMP users, so we'll come back to him later. I think enough of you have voted. Now we're going to close the poll and just share the results, just so you know how you sit with the rest of our audience. Probably not unexpectedly, there's a chunk who use it frequently, but not the majority of the audience. 17%. 45% of you, most of you, are there in the occasionally using design of experiments, but not every time. And 38, a sizable chunk of you, not using it yet. You will see some really strong examples today as to why that is perhaps a mindset that you want to start working in, and ways that you can start to approach that on a personal and organizational level. Thank you for filling in the poll. Keep your questions coming in. We're going to go to the second part of the video now. Pilar, you have been something of a change agent within Johnson Matthey. You've been an advocate for design of experiments for quite a long time. Could you just give us a quick overview of what design of experiments is and what it was about it that appealed to you?
So again, design of experiments means different things for different people. Actually, it's a word that confuse a lot of people if they think that it's all about just planning the experiments, and design of experiment is a lot more. Design of experiment, it is what it is because you use the analysis after. So in reality, it's the whole process. Since you are collecting data and planning the experiment, collecting the data and then analyzing it, interpreting it, and also passing the results to someone else. So it's the whole process. That's one of the things I want to say. And the other thing that design of experiment means for me, it is the only way to do research in an efficient way. It is the future. It will come. It will come like a wave. Some people will catch them standing up, and other ones no. But it will come. So this sort of experiment is not new. I learned it in the university, doing it by hand. But now it's accessible. It's the technology, the software will make it accessible to everyone, and that's the beauty. And I think we need to be as quick as possible to adopt it, because we will get the advantage, I think. So that was this experience for me. The only way.
Yeah.
So it's broader than the pure statistical design of experiments technique. This is really about embedding that philosophy into the digital chemistry journey that we've already been talking about.
Yes, I like to say that once that you are inside the design of experiments and the statistical tools in general, your mind change. I used to call it is the DOE mindset. So every chemical problem or every challenge that my colleagues present to me, I see it as a table with columns and rows. And that's what I see. I transform everything in a table with columns and rows. Yeah. And I've seen people that I train doing exactly the same than me. It's a total change in your mind that in the end, it takes people to be able to transfer all that knowledge. That is for me the beauty. At the end of the process, at the end of the experiment, you will have a model and you will have a conclusion, and you can transfer both things to people so they also understand it and prove it. And that is for me the beauty of everything.
Yeah, and I think that's really important, because it doesn't stop at the design; it stops at the knowledge that you get from that at the end. That's.
And people can continue, people can grow it.
Yeah.
So the DOE never finishes. You keep adding more experiments. We like to say it's a sequential approach. So you keep adding more experiments, and your model gets bigger and more applicable in more areas. So you never lose the data. You never throw it. You don't start again from zero. It's a kind of building, and that's what I think we should be doing. We should be building on our knowledge in that way, in a way that we can transfer it easily to the new generations, let's say.
Yeah.
That's very compelling. I am convinced. But how did you convince other people internally at Johnson Matthey? How did you get this up the ranks to the people who were able to actually facilitate the change that you wanted to see?
To the leaders.
To the leaders.
Well, to the leaders, you have to talk about value. That's what they want to hear. They want to see what is the outcome of it. And we pitch it to Liz and the team, and we show the value. So we show cases. So you need to prove it again. So we are all technical. So we like to see the proof. It's like you saying this has this value. Show me the examples. So we show examples and we show the value. We show the comparison between doing it traditionally and doing it with this kind of experiments. And we did our own calculations. And we realized that we were actually saving 50% of the R&D time and resources in almost all of the cases. So I think that was kind of compelling. I hear you using that number, so I think you need to tell them a number because that's what we all like to remember. And it's about the value.
Yeah. And as I said, doing a good experiment is really expensive, actually. If you think of all the resources that you need, the infrastructure you need, and the people and the time and the equipment to do that, you want to get the most value out of that. But a company like ours, we spend an enormous amount of money on doing experiments, and you want to get every little bit of value you can out of that. So
saying actually to the decision makers that they can save 50% of that time, or what I like to say better, it's like they can use that 50% of resources
doing
else.
even more experiments.
I think it's very compelling. I think.
And I do remember Stephen and Pilar knocking on my door one afternoon and saying, we would like to devote Pilar's time to really looking at statistical analysis and the use in our company, and we would like Pilar to train others to do it. And you came, I remember it distinctly, and we said, okay, that's what we'll do. And that's what we have done, and then tried to, and we have a small team in the core function doing this, but we have managed
a very
to reach.
Structure,
Yeah, it's the structure, I think, that
we have a
makes it
structure,
work.
we have a lot of ambassadors, so this is kind of the motivated people in different businesses that have been trained first, and they are spreading it around them. So we have kind of our structure. That is the structure of support that hopefully will stand there for very long.
And I think scientists are sort of natural collaborators like that. They like working with each other, in fact. So they like helping each other and working with each other, and so that approach works really well in an R&D community, I think.
And in the manufacturing as well.
Yeah, and in the manufacturing
exactly.
community.
It's not just about R&D.
I
think there has value across the board. And I think your point about learning from each other, that's what science is. You do an experiment and someone else learns from that, and you become greater because of the sum of the parts. And that's really what we're trying to do.
Teamwork.
So were you just immediately swept away on the wave of Pilar's enthusiasm, or did you have some initial hesitancy about devoting the entire member of staff just to looking at this approach?
Not really, because I think you came with some really compelling case studies, so it was quite easy to say yes, actually. And I could see that it would really help us be more efficient. And you do need someone who's passionate about it. So Pilar was very passionate about doing this, and I thought that was half, going back to that people thing. If you've got someone that's really going to drive it makes a big difference.
So was there a particular sort of was there a number, was there a term?
Well, I'm afraid I did like the 50% reduction in experimentation, and I still quite like that. So, and that's something you can't, that's really important, because even when you're talking about sustainable technology, if you're reducing the amount of experiments that you need to do to get to the end result, that is a sustainable approach to R&D. You can't help but innovate more quickly in that space. I think the other thing it does is it does direct you to the outcome that is most successful, which sometimes you can spend a long time iterating through to an optimized view. And again, your point, Stephen, that we do a lot of experiments in Johnson Matthey. So if we can make that more efficient, gets us to the end solution more quickly. And also the fact that we're passing the training through to development, through to ops, manufacturing, you're all using the same approach, then things are more easily transferred. And that's very important in a manufacturing company. Tech transfer is always a very difficult step. So, anything you can do to make things more transferable more quickly, that's very compelling.
And I think that's by having the right approach, having that sort of more robust model of what your systems capabilities are, I think makes that process a lot more robust when you try and transfer it, because you actually understand what a lot of these different parameters do. So you haven't done I guess the danger is if you do a narrow set of experiments and you get, it works under exactly these conditions, which are actually really hard to replicate in manufacturing, then there's a danger that then it can go wrong in that tech transfer, isn't there? But if you've got a more robust model, but you've done a bigger scoping study and you've understood it properly, then I think it makes that whole process a lot better. So I think the technology becomes better as well as the.
It does. I agree.
Rather than just the cost, the whole thing becomes better.
Yeah.
So clearly Pilar's passion was easily enough to convince you, the passion and the stats and the evidence. But Pilar couldn't individually go to every member of staff at Johnson Matthey and exude her passion for this approach.
She tries.
A decision had to be made essentially from on high that this is now an approach we're going to accept. Did you see any resistance to that, and how did you manage it?
Oh, I think because also, our colleagues in the businesses were using statistical analysis, and there was a natural pull for it, I think. And so we're still on the journey of teaching others how to use it that aren't in that space at the moment. But those that were also easy to bring along with us. And, I think if you look at any part of the business where you're trying to make your result, your outcome more efficient, more quickly, people genuinely would want to do that. So I don't think we've had resistance. I think somewhere we've had people that don't understand it, and so that's where training comes in. And I think your approach of building a cohort that learn together and share their problems together and solutions, fantastic.
Hello again, I'm back. That's the second part of the video. There is still more to come. I'd be really fascinated to know if the sorts of issues and approaches that we've seen from this conversation reflect what you've seen in your own work and your own organisations, especially the solutions. Do let us know if you found similar solutions or ways to apply these sorts of solutions to achieve significant and impressive change. I'd love to hear more about that. You can drop it in the questions chat or something like that. But right now we're going to roll another poll to try to get to know you as an audience a little bit better. Here we are. So which challenges are you facing in your organization when implementing a digital strategy? Is it just simply the adoption of it? Is it finding or deciding on the right tools to use? And there are a lot out there. Or is it management support? Is it perhaps that there isn't the motivation above you, that things are working well as they are, don't necessarily see the value in the digitalization changes that you think we need to adopt in order to be competitive and to stay on the cutting edge of chemistry? Let's give as many of you as possible opportunity to vote in that. And in the meantime, let's have a look at some of the questions that have come in. Jyoti has asked a question about career opportunities in digital chemistry. Now, we're going to talk about some of that coming up, in particular talking about how you can skill yourself up in advance, perhaps while you're doing a degree or even while you're in work, and how these sorts of skills can be more broadly applicable throughout chemical careers. So keep an ear out for that in part 3 of the video, and then we can ask that again to our guests at the end if there are particular approaches, particular things that they would like to see when they're recruiting, and ways that you can demonstrate your own digital chemistry skills and how those can be of value to an employer. So let's see, I think enough of you have voted for now. Let's get that poll closed down and share the results once more so you can see how you sit in this audience. 27% of you, so a quarter of you-ish, you've got your digital strategy in place. It's simply adopting it, getting everybody on board, the onboarding process, that's your problem. The majority of you, the problem is that bewildering array of tools and platforms, choosing the right one, finding one that does everything you need to do, knowing exactly what scope you need, because these are significant movements, significant investments. You have to invest time as well to learn a new platform. So you need to know that the support will be there as well as the tool itself. And 30% higher than I would like to see, but perhaps not higher than I expected to see. Simply find they don't have the support from on high. Perhaps the people making budgetary decisions are a little less enthusiastic than you are for these sorts of big investments, even though you know it will make significant changes. Let's get into video part 3 now, and then when we come back later, Phil Kay is going to give us a little demonstration of JUMP and how you can, as a case study, present these sorts of results that clearly had such an impact at Johnson Matthey. And then we'll go into that wider Q&A with all 3 of our guests. So enjoy part 3. Pilar, we've clearly identified that there are gaps in technology and there are gaps in skills and data literacy. How do you at JM go about finding and plugging those gaps with training?
Well, it's like luckily I sit within the organization in a position in which I have access to many different businesses. So I'm very fortunate. I feel I'm very fortunate to know a lot of challenges from many different people, and I can see the commonalities. And I also go into training, into a lot of workshops and things, and when I see solutions, and then I can see how they match and how I can apply. We can apply different things into different challenges that we have in the business, and I choose motivated people. So if I have to try new things, I choose motivated people that are willing to try things. So that's, I think, how it starts. Then once that you prove you pass the first step of trialing something new, filling a gap, and finding a solution for a challenge, then it gets spread naturally. So the word of something has gone okay will spread naturally and people will adopt it. But I think it's very important to find people that are motivated to try new things, to solve something. So, and it helps that I have a very good position between businesses, and I would say a broad knowledge. So I like to say I'm expert on nothing, but I know a little bit of many things, and that helps to talk with my colleagues. I have a special position. I can speak the same language of many different people, and kind of translate. So sometimes I'm a translator between, I know the tools and the solutions, people know their challenges, so I'm in the middle trying to understand, to try to do the matching between the solutions and the kind of gaps and challenges that they are having. So I'm a translator.
But I think the other thing that you do really well is that you offer lots of different ways of learning. Because, you know, different people
Yes.
are different, aren't they? Right? They like to do things in different ways. Some people like doing stuff on their own. Some people like a one-to-one. Some people like interacting with people a bit more and having a seminar or a workshop or something. Or some people just like listening to a lecture. And all those things you offer. So it sort of suits the individual sort of taste of people to learn, doesn't it?
And you probably don't need everyone to be at the
No.
same level. It's like coding. You don't need everybody to be a master coder.
No.
But you will want your organisation to be trained at the level that they need to be trained to do what they have to do.
So clearly you choose motivational people to bring new skills into the business initially. How do you motivate everybody else? There are clearly people who are very interested in adopting this. Maybe they see it as an important part of their future career. But there are other people who perhaps aren't all that interested in this and like the lab work. How do you motivate and incentivize them to develop the new skills that you need?
So I think one part is very important, that the leaders and the people managers reward them. That's very important part. So I try, for example, to communicate with the line managers to make sure that I say to them, this person is doing an amazing job. So they get rewarded from the line managers. I think that is always very important. And to motivate them, I try different, because people have different motivations. So some people will do it because actually it's saving time for them. Some people will do it because they like the line manager to tell them you're doing great, and there's no problem with that. Some people need recognition, and some people will do it because they fancy new things. So there are a lot of people that like doing new things, and some people will do it because the one next to them is doing it, and he wants to do it as well, doesn't want to be the last one. So it's kind of offering different ways. I do webinars, we do different kind of trainings, workshops, publish blogs, different kind of ways that we'll call different kind of people and try to kind of call their different motivations. Yeah. Some are more difficult than others, but we try. So we are working hard to make sure the tools are available for everyone. So that is not the challenge
And I think
anymore.
you know, in different functions, it's the same thing always. You have to make a business case for the things that you need to do your role more efficiently, and once you have that, that's you know, it doesn't matter what it is, does it? Whatever if it's I don't know, equipment, capex, whatever it is. You have to make the business case because there's finite resources. So
yeah, because there is a cost attached to it, so it's always a conversation. But it is true that I think it has been improved. That if people have a tool available, it's more probable that they will use it. Yeah. Training is a process, but acquiring the tools as well is a process.
Speaking of processes, so processes generally have an endpoint. They have a goal, they have an aim of sorts. It might be part of a wider strategy. How will you know when you've got there? Will you even recognise when you've got there? I imagine the people that put the BBC Micro in your lab thought, well, this is it now. We've computerised, and probably didn't have an idea as to what to come. How will you know?
It will never stop.
I think so. And
life is moving so quickly. It will never stop. We will have to be continuously up to date. But I'm very humble on that. So for me, every little thing is a little success. So we have a scientific conference, and when I can see 4 or 5 people talking about DOE there, that is a success for me and for all of us that we managed to do that. So that for me is like, you see, this is changing. You can see the evolution of the things that people are presenting, and you can see that it's increasingly more people are using data and statistical tools and design of experiments. So I think it's going to be a progression, and I think we have to be humble about it, and I think it's never going to stop.
How do you think universities should change in order to give you a brighter pool of candidates who do have a more diverse set of skills?
I think they're already doing that, actually. I think they're combining. What they are doing is trying to break down the silos in the different departments. So they're cross-training computer scientists with physical scientists, and they're very aware that that is a skill set that's very marketable as well. And I think the early career scientists definitely want that data science piece. They want to be able to code. They want to be able to. They want to be quicker and more agile and flexible. And I think that they ask for that kind of training.
Yeah.
But in the end, it's like I was trained design of experiments 25 years ago, and I was not trained in chemistry. Why? It's like I don't understand that. It's like I think I'm a chemical engineer by background, so that might be the difference. But I think it's like design of experiment is not new. So I know it was difficult. It's stats, and it's always kind of difficult. But I think we could be doing better. I think, and also it's like let's recover the stats, because now everyone just wants to hear about data science, and I think people need to be having the principles okay. So I do have a lot of people that say to me, "Oh no, Pilar, I don't want to know about statistical tools. I want to learn machine learning." And it's like, okay, you want to do machine learning? Let's learn some basics about statistics first. So I think the universities have an opportunity to come back to that, kind of make it more simple and more practical. I think that was the problem. People learn statistics in the university, but not in a practical way. So when then they don't apply it. So I think there is a lot to do there on that side.
I think the biologists, I mean, when I did a biological
there, isn't it?
medicinal degree, I was taught stats when I did my degree.
Yeah.
But we didn't have the software tools that you have now. So, I mean, that's the difference as well, isn't it?
Yeah, it's much more.
So I think I've really honestly noticed that universities are much more focused on trying to grow these cross-discipline skills. But you're right, do they do a lecture or a course on design of experiments? I have no idea, actually, but I will be asking.
So the sorts of skills that children are developing at home that clearly universities are heading towards, it sounds like from a digital chemistry perspective, we're going to have a really good cohort of new fresh PhDs and fresh grads in a few years who do have a more diverse background, more diverse range of approaches. Do you see the future for digital chemistry, and especially in a business like Johnson Matthey, to be really bright, expanding even quicker and developing even further? Do you think you're only on the first step?
I do. I think we're at the beginning, and I actually think the skill set is difficult to find. But when you do find it, it's extremely powerful. So we've also started kind of growing our own. So we've combined forces with our colleagues in IT, and we're funding joint PhD students in physical and digital science. And these are all small steps, but I think also, you know, if you come in at a degree level, you come in with maybe an agile mind, and typically our degree scientists can code already, and they are adept at thinking differently. And then if you're doing a PhD in material science where you're using good digital approaches to the materials design, you know, those are the types of people that I think will be very successful in the future, instead of a laggard like me.
But I'm sure it's not like that, but in the end, it's like these new skills that they learn now are very good, but let's not forget about the fundamentals. We need the two
Absolutely,
parts.
I think your point about...
They come very trained, a lot more computer savvy, a lot more, they pick things really quickly, but they still need to be trained about what we know, and they like to hear it. So if we can get the two things together, that would be amazing.
Yeah, agility and the experience. But that is about science, isn't it? That's where you share your knowledge. I mean, that's the whole point. Sharing your knowledge and learning from someone else's work.
Yeah.
That's what science is, isn't it?
Yeah. It's more fun that way as well.
Yeah.
And there we go. Huge thank you to Elizabeth Rousel for giving us so much of her time on that day to have that sort of conversation and to be very open. Quite often we find senior management at big organisations can be quite guarded, and Liz was an absolute dream to chat to. And as I'm sure you saw there, very friendly, obviously knows Pilar and Stephen very, very well. And so I think that really helped to bring the most out of all three of them. And speaking of Stephen and Pilar, we're going to get them back on screen very shortly to answer some of your questions. But first, I would like to introduce Phil Kay. Now, Phil has done a lot of webinars with Chemistry World before, demonstrating the power of JUMP software and the power of that DOE mindset that we've been chatting about. Phil, thank you so much for joining us. I will break the fourth wall and reveal you were actually in the room with us for that conversation. You've seen all of that before, so you knew already the points that they were going to make, and that I think has helped you to just put together a brief demonstration of what JUMP can do and how we can use JUMP. We've talked about how you can use it in influencing and so on. Let's see what it can do in the flesh. So we've got your screen up now, so I'll hand over to you and then we'll come to Q&A afterwards.
Great, thanks, Ben. Yeah, so I think about 38% of you said that you weren't using design of experiments yet. So this is very much aimed at you. I want you to understand what design of experiments is, why you'd want to use it, and what the value is. So in this case study, some scientists had invented a new catalyst technology for turning waste carbon dioxide into useful polymers. However, the process wasn't very efficient, so the yields were low and they were getting high amounts of a byproduct that was undesirable, that cost a lot to remove. So they really need to understand how to improve this process, get better yields, reduce the amount of this byproduct formation. But there were just so many different things that they could change. They brainstormed it and there were about 35 different variables or factors that they thought they might need to change, control, set in order to optimize the yield of the process. Now they managed to reduce that down with a bit of a combination of using their existing data, exploring that with visualization and machine learning, and their chemical engineering, chemistry, physics knowledge. And they got that down to 10 factors, 10 things that they could change that they thought were likely to be important. So these are formulation type factors, recipe variables, the amount of certain additives, and some process factors, things like temperatures and pressures. So they need to understand how these 10 things might affect their important outcomes, the responses. And the only way to do this is to do experiments. There's no textbook telling them how these things are related. Now, when you consider just 10 factors like that, you might want to experiment with each of them on 3 levels, so a low and a medium and a high setting of each, which sounds relatively simple. But when you consider that you've got 10 of these things and there are 3 possible settings of each of them, that means there's actually tens of thousands of possible combinations. In fact, there's nearly 60,000 different ways that you could set each of those 10 factors at 3 different levels. So the possibility space is just overwhelming. There's no way that you could possibly test all these things. And this is what design of experiments is about. With design of experiments, we don't need to test all of the possibilities. What the scientists here did was they actually just tested 24 of those. They did 24 trials of the process with different settings according to a strategically designed experiment. And they ran these 24 trials, they got the yield information from each. They also got the byproduct formation. We're not focusing on that today. And with that data, they could start to understand how these different factors affect their important outcomes. So the yield is their most important outcome, and they could just quickly see how temperature relates to yield. And actually, it looked like there's an optimum temperature somewhere in the middle of the range. The range has been disguised here to protect the IP. So we're only seeing -1 to 1, but the real temperature range, they were able to identify what the optimum temperature is. And they don't just understand things one factor at a time. With this data, they're able to fully characterize this process to understand all of the factors. So all our factors are on the x-axis here. So this is the relationship between yield and temperature. And they were surprised to find actually that there was an optimum lower temperature. They'd previously been running at higher temperatures. And they could see that monomer catalyst ratio was important and how to maximize the yield by controlling that, and the water. And then all of these other things turn out to not be very important. So they could actually just take out some of these additives. They didn't have to worry about how they controlled pressure within those ranges. They could use 100% bulk monomer. So simplify this process. So this designed experiment approach very efficiently, very rapidly gave them an understanding of which factors they needed to control and which ones they didn't need to worry about, and how they needed to control them to optimize the process. And this knowledge enabled them to actually sell this technology for an awful lot of money. And just to give you a quick idea, designing an experiment like this can be very simple. It's really just a case of defining what your outcomes are, the responses, and your factors, and what range you're going to experiment over. And once you've done that, there's very few decisions that you need to make in order to design an efficient experiment that's going to enable you to learn about your process or your system so that you can speed your innovation. So I think it'll be time for some Q&A now.
Super, thank you, Phil. I think the other point that needs to be made about JUMP in particular, not necessarily the statistical approach, but the way that JUMP is built, is it's so intuitive when you look at it to see those results. And if you are trying to communicate to somebody who, say, is a finance manager and they need to make a decision about spending, they don't necessarily understand the statistics underpinning it, but you show them a chart like that, you show them how it changes live. You can really demonstrate these things to people who don't need to know the ins and outs of the chemistry when you have a tool like JUMP that will allow you to visualize it.
Yeah, it's also about being able to communicate your insights in a clear and compelling way that are going to drive change, which I think has been very much the theme for today.
It has. Well, and speaking of today, Steve, let's get Pilar and Stephen back up. Let's get your cameras up and check that we can hear you. And while we are firing that, I'd just like to, last minute reminder, any questions you want to get in, we have about 8 minutes to get questions in. We've already got some good ones, but that doesn't mean that you shouldn't ask yours. Do please get your questions in now. Let's dive in with something that I think you can all broach a bit that's come in from a few different people. So Ali has asked something similar, and who else do we have? Jonathan up there, I think. Generally, when you are a chemistry student, what skills can and should you be picking up? So Phil, from a JUMP perspective, what skills would help people to use these tools? Stephen, Pilar, what skills from a more corporate Johnson Matthey perspective, what skills do you want to see the workforce having? Let's start with Pilar, because Pilar was obviously the main driver of change at JM, so it's good to get Pilar up first.
I think it's like the fundamentals have not changed. It's just kind of the practical way on how to apply it. So I think sometimes people ask questions about, but if we want to teach some skills, we will need to remove the others. Is that not really? I think it's about for example, is like when it's practical, because statistics is still a study in a school and in the university. Is that is not with that practical twist. Is maybe more theoretical, and people don't know later how to apply it. So it's more in the applications, in the labs and in the demonstrations. It's about using it practically, because that's kind of the muscle memory people then have. Is more than the exercises, more than the theory. So we wanted to be able to use it practically. Makes sense?
Yeah. Stephen, you're a research manager, so you perhaps have a sort of slightly more of an overview. What sort of variety of skill sets would you hope to see?
Yeah, I was going to say, Ben, it's a long time since I was a student, so it's quite hard to remember. But I would also say I think that you're looking for the willingness to learn as well, aren't you? Right, because you might not expect everybody to come in with expertise in lots of different areas, but you do want people to have openness. And if I think if they can demonstrate some awareness and some knowledge and some of the benefit of these skills, I think that's great. So you don't necessarily have to have everybody coming in as an expert, but I think a willingness to learn is really positive.
And Phil, what do you think people should make sure that before they get into the world of using something like JUMP, and actually, that perhaps A-level and above, what sorts of baseline skills do you think really help people to make the most of these sorts of platforms?
I think it's starting simple, really just this concept of how we learn from data. I don't think you have to go into t-tests and normal distributions and all this kind of thing. I think that puts people off very quickly. So I think just I love how sometimes you can just learn things very simply just with some simple visualization. And I think if you start by understanding just how we learn from data and how we learn from data from experiments, then I think that sets you in good stead for learning some of the more advanced things that come along the way.
And those are critical thinking skills that apply across the board in any field you could possibly find yourself in. Pilar, interesting question from John Henning here about clearly you have established yourself sort of as a hub for DOE knowledge within Johnson Matthey. John Henning's wondering how much of your time in your current role is used in that sort of education side of it, and how much of it is used in the other parts of your role. Do you find that most of your time now is about changing people's minds?
I do 100% on that. So that was the 100% on supporting people. That's how I call it, supporting people. So that's one of the big things that happened, that changed in Johnson Matthey when Liz decided to give us my time to be helping and supporting people, and now we are more than me, so we've grown. So yeah, 100%. I think it was very difficult. So at the beginning, I was doing it as a side job, as a side thing, and at some point, Stephen here said, Pilar, you should be doing that. You should be doing 100% training people, helping people to do the same that you do. And yeah, we managed to convince Liz, and that's where we are now. Now it's people convincing other people. So some of the convincing people is done by the people that I already trained. So I sometimes don't have to say anything someone else is saying. Yep. Have you thought about doing a DOE? So I don't even have to say it. So yeah, I think it's really important. I think it's really important that it is someone supporting. And I'm not an expert. I always say it. I learn with all of them because I have access to many different cases. So I'm so fortunate to help you in many of their challenges that I always learn. I learn about a different way to do it, about something we need to do differently, or we need a new tool. So it is a journey, but you obviously need dedication. You need to dedicate the time. It's important.
Yeah.
It will pay off.
Yeah. It's like with a lot of things, isn't it? You need a really powerful advocate to start things off, I think. But once you've established that, and once you've got a community established, then it can really grow on its own, can't it? But with you have to provide support. But it's important getting that going, I think.
And I can say as well. Oh, sorry.
That's right. Just saying, once you've planted that seed, all it takes is a bit of water to keep growing, as it were.
Yes, and I can say maybe answering now because I'm 100%, so it's a different world with that spread the world. Are actually maybe they have 10%, 20% of their time helping others.
We don't have much time left, but we've had a couple of questions about machine learning, AI, and that sort of thing. And I think it's something that Pilar mentioned as well, that people come to us saying, I want to learn about machine learning. And she said, well, let's take a step back and let's get that statistical grounding before. I think Pilar's camera's frozen, but hopefully, Pilar, you can still hear us.
I can still hear you perfectly.
Excellent. So given your fondness for DOE, you perhaps might have a strong opinion about this. Is a method like design of experiments still relevant in an age of AI and machine learning, when you can just, given a vast amount of data, and let AI and machine learning devise all your models for you? Phil, clearly I know you're going to have an opinion on this, so let's let Pilar have a go first, and then Phil, we'll come to you.
More than ever. More than ever. It's like you can have all the data you want in the world, but if it's not good, you're not going to find what is not in the data.
Yeah.
So you can mine wherever you want, but you're not going to mine if it's not there. So, and also, is that what we want to do? It was you just have vast amount of data based on no expertise or anything. That is not really true. That's not the real world. That's not what we live in industry. It's like you need to plan the experiments to take the data that you need. And that's how it works, and that's where the best. So we always start with people with data they already have. It's a very good way to start. It's like pull all your data into the software, and then let's start plotting things, doing graphs, analyzing and realizing where the gaps are and where are the things that are not very well understood. And then you show people, actually, you need to build on a DOE. So then you build a DOE on top of the data you already have, and you realize that it's incredible that with a I have someone say to me, Pilar, with just 13 experiments, we learn what we haven't learned in years. Like, yes, that is it. So then you quickly realize that you don't need much data to find out, and that you pull your expertise into the design of the experiment. The combination is very powerful. It's a lot more powerful than having thousands of rows that are not valuable for what you want.
Bill, I'll let you espouse your opinions about AI and machine learning from a design of experiments perspective.
Yeah, I love them. I don't think they can supplement DOE. They can be a great thing, but they're definitely not replacing DOE. I don't think it should be any surprise to anybody that you don't generally have a lot of existing data if you're making something that has never been made before. So this is why we do the experiment, right? It's because we don't know what's going to happen. Nobody's ever done it before. We're making new catalysts, or we're making new, clean energy technology that nobody has ever made before. So there just isn't, unfortunately, we don't have the huge amounts of data that you might have if you're working in, Netflix or Amazon or something like that. They have huge amounts of data that is directly relevant to answering their questions about how they can sell more stuff to you. As a scientist, we're doing new things completely, so we shouldn't expect to have all that data that we can use. We can just plug into machine learning.
But that's why we are needed. That's why scientists. That's why we are needed. If not, a monkey could do it, but I can't.
Yeah, we're not trying to do it blind, are we? Yeah.
No.
Super. And as Stephen alluded to earlier, the being on that front line of discovery, that's where the fun is as well. I think we have run out of time, really, but thank you so much for all of your time in that interview with Liz, as well as all of your time here today. Huge thank you to Jump, who helped us organise all of this, put us in touch with Liz, found us some fantastic speakers for today who've been able to tackle your questions. I should add, Jump, we've been talking about sort of design of experiments, but Jump, it has a sort of family of statistical discovery products used worldwide in almost every industry. So even if exactly what you've seen today, even if you're not designing new cutting edge materials or brand new compounds that nobody's made before, I'm certain you will find that Jump has a solution or a family of solutions for you that might help improve your processes, handle your data better, etc. So Jump, very happy to work with Jump on projects like this, and I look forward to working with them again in the future. So a final thank you to Elizabeth Rousel, Director of Johnson Matthey's Technology Centres, Pilar de Mezes, who is a Principal Scientist at Johnson Matthey, Stephen Poulston, Research Manager in Corporate R&D at Johnson Matthey, and Phil Kay, Learning Manager for Jump Statistical Discovery. And thank you to you. Thank you for joining us. Thank you for your questions, for getting involved in the poll, and for watching those videos. I'm Ben Valsler, Chemistry World's Digital Editor. Keep an eye on your inbox for a link to the recorded version of this and also your certificate of attendance. And I hope to see you in another Chemistry World webinar where we can answer more of your questions and help you plot a course through the chemistry world. See you again soon.